I primarily work on Android, and I've also worked with a lot of global brands like Tiffany, Mizuno, Tata Information Systems, and Glenlivet. And currently, I'm working for an organization called as Kite. Kite Cash is an organization that works towards financial inclusion for people here in India. So we are doing a bunch of interesting stuff, and this talk is something is related to something that we solved at Kite recently, right? And there are a few key takeaways from this talk. One is like, one of the things would be to help you identify the kind of tasks that developers should not be doing by themselves and to automate them. And code generation itself is one of those techniques. It's just one of the technique to automate something that you do repeatedly. So automation can be even something very simple like writing a script, a shell script that can actually do things for you, right? So this talk is about how we actually leverage code generation to generate some code for both the platforms, Android as well as iOS, right? And there's also one thing that I constantly see when I meet with a lot of developers. There's one thing that actually distinguishes really good developers from developers that are like upcoming developers. So that the way how you see yourself has a very prominent impact on how you solve problems. So when I tend to ask someone like, what do you do? We usually say that I'm an Android developer, I'm an iOS developer, or I'm a React Native developer. So that kind of mindset puts a block whenever you try to solve problems, because whenever something that is not relevant to your area of expertise, see for example, there's a really good article on reactive Java, but you are an iOS developer, you're not going to look into it, right? So the way we have as developers have to look at ourselves is to we have to look at ourselves as problem solvers rather than Android developer or iOS developer or like a web developer. That way you can actually learn a lot from other technologies and then apply it in your own area of expertise, right? So let's go and look into this problem. So every organization at some point of time, be it whether you're doing web applications, whether you're doing Android applications, or whether you're doing iOS applications, you always have to collect a lot of intelligence from the application, right? So you have to include some sort of tracking code to your application. That way you collect data, and then your product owner or your business intelligence team, they start working on that data, and then they convert it into meaningful metrics, and that also drives the way on how your product is built, right? So analytics is also it's a cross-cutting concern. Like, people don't actually talk about it or think about it a lot, but we keep doing it on a regular basis, like whether we like it or not, right? So let's see how we do. I'll just walk you through how it is done. Like, you guys already know how it is done, and then I'll just give you a refresher on how we actually do it. It's like pretty much common sense. So what you have is here is a screen. So this is the dashboard, and then if you want to withdraw money from your account, what you do is, like, there is this cash out button. You click on it, and then you have a bottom navigation sheet that shows up, and then you pick that you want to withdraw money into your bank account, and then you enter how much money you want and do all this stuff, right? So this is a workflow. So when you say you want to withdraw money, so it is a workflow, and then that workflow puts you through several screens, right? And in each and every screen, you do a certain action. Say for example, if you're on the dashboard screen, clicking on the cash out button itself is an action, right? So it is part of the workflow, but it's just one event in one screen. And in the next screen, what you do is, like, you go and enter your amount, and you probably may click next, right? And when you click on next, then you go pick your bank account, and then you do a confirm withdrawal, and then probably another screen shows up, and you do a withdrawal. It's either going to be successful or failure. So there's a bunch of data that you can collect from this workflow, right? Bank accounts, or IFSC code information, whether the user entered the right amount, or whether he canceled, or whether the transaction was successful or it failed. So there's like a bunch of data that is in the application, and you actually collect these information so that you can improve the process for your users, right? And then it's also very basic how we do this right now. So this is like a code that is in Java. It's for Android. So you have a Mixpanel. So instantiate it, get an instance of your Mixpanel from your SDK, and then you create a payload. A payload is like just a collection of key value pairs, right? So you get some keys, you add some values to it, and then what you do is, like, you just fire away so that there's this data is sent to mixed memory, right? And then you also do this in other platforms. Say, for example, iOS. So iOS, it's a lot more cuter, right? So you have a bunch of properties, key value pairs, a dictionary, and then you send it to mixed panel. That's it. You're done. You call it a day. You know, usually these code is very cute. I would compare them to gremlins, because especially the one that you did in iOS is very small, very cute, and then it's easy to write. But the problem with gremlins is they are really cute. Now when they're young, they're really cute. You may want to not take your eyes off them because they're so beautiful and so cute, but you don't want to be around them when they're grown up and then there's a lot of them, right? So you don't want to be in this situation. There's a lot of grown up gremlins out here. So when you start writing analytics code and then you get a hang out of it, you're still doing the same thing over and over again, and then there's a lot of duplicated code, there's a lot of data that could be wrong, and then there's a lot of copy pasting going on. So this is something that you don't want to be solving in a brute force manner, writing down all these things in one place and collecting it. And how the data and what data you want to collect is communicated to you with different means. Say, for example, our business intelligence team used to give us this Excel sheet, right? So it had a large number of columns. It's not just 4 columns, it's A, B, L, and M. So it's a lot of columns, right? And then there's just probably now we have more than 500, right? So you don't want your developers to be looking into Excel sheets and then saying, okay, this is the key, this is the value, this is the screen, okay, this is the event, and I'm going to do copy and paste, right? That's very, very inefficient. So you don't want your developers to do context switching, right? Probably you may want to have a secondary monitor. You don't want them to do all tab, it's crazy, it's insane, it's really difficult to do this stuff. So how do we solve this problem, right? So first of all, the approach, when you have maybe wherever you get the data from, it's from your database or from my Excel sheet, if you try to copy and paste it into your code, then there's a lot of problems. It's slow, it's extremely boring. You don't want to do it yourself. Probably if you have an intern or a junior developer, I would actually push it to them though. So no, so that's a fact. It's extremely boring and it's also inaccurate. You don't know if you make a mistake at one point of time and that you're going to collect the wrong data and your business team is going to get the wrong information. So these are inherent problems that come with adding cross-cutting code, addressing cross-cutting concerns like analytics in your code. So we also had multiple platforms, Java, Android, and we also had iOS, and we also had multiple applications coming in. So we need a solution that is really robust and then can handle a lot of things for us and for other developers that we work with. And what were our requirements? So we looked into the problem and we thought these are the things that we definitely want, which is accuracy of the data that we collect from our users. And we also want to make sure that if the business team changes its mind, or if the design team comes up with a different screen, then the approach that we come up with should also accommodate all these changes, right? And when I talk about cognitive resources, each and every individual has very limited set of cognitive resources at every single day. Say, for example, if you're on your working on something really interesting, and then someone interrupts you, and you're not going to feel good about it, right? So then you're lacking cognitive resources. And sometimes if you have to remember something on your mind, then you're lacking cognitive resources, right? You're switching between multiple tasks, then you're lacking cognitive resources, right? So imagine a developer, maybe you give him a second monitor and the sheet is on the second monitor and then the app is on the left, on the main screen, then it's still a lot of context switching. You don't want that to happen, right? And testability, we also needed a certain degree of testability. Testability is very subjective because people also tend to ask who tests code, tracking code, who tests analytics code, probably never happens, right? So that depends on how vested your company is in the kind of data that you're collecting from, right? So it is very subjective, the amount of testability that is required for different teams that could vary, but we did require a certain level of testability in the solution that we were about to roll out. And then this one is obvious because we've had multiple apps and multiple platforms to support. And then how do we solve this? So what does a good developer do? Anyone? What does a good developer do? How do you solve really good problems? So being a good developer, you don't try to solve it at all, right? You look for people who have already solved it, right? So if you're a really good developer, you say, okay, I have this problem. Has someone already had this problem, right? Chances are someone may have had this problem before. and they may have solved it in much more elegant way than you have, because they have simply spent more time on it, right? So we went out looking for solutions, like whether do we already have solutions in the market for this. And then sadly we didn't have any out of the box solutions, but we did come across one solution that was very declarative. So it was an Android library that you can use annotation to declaratively collect tracking information, but it's still not applicable, because there are certain, say for example, if you have very complex logic, then bringing in annotation processing would be one problem. And the second thing is it used aspect J. So if we were actually modifying the generated bytecode, and then when your application crashes, the line numbers will not match, right? So we found that solution was declarative but elegant, like immediately looked at something that we could use, but turned out it has other side effects that were not designed, right? So we thought, like, we were not able to find existing solutions in the market, so we thought, like, okay, let's go and look at the problem again, and then our problem was this sheet. So once we started looking into the sheet, we kind of came up with this relation. So this was the entire relation between things in the sheet, right? So every time we came across a row or a record, we had the workflow, so which would be the process, which is like cashing out your money. And then the screen, so it could be the screen where you're entering your money, or you're picking a bank account, or confirming your withdrawal. And then there would be events, which would be like the user picked cancel, user picked entered 200 rupees, things like that. So everything on the sheet had the same relation. So we thought, why not we turn that relation from this to this, right? So you have workflow, screen, event. So how do we actually make it much more easier for developers to integrate tracking code into the applications? So then we found this library called JavaPoet. So JavaPoet is a library from Square which allows you to generate Java code using Java code. So it's a Java library. You can write your own application that does JavaPoet. So JavaPoet is also used in annotation processors, so which is a completely different topic. And this particular solution, we did not go for an annotation processor. It was just a Java project that was capable of generating source code for us. So this is a very simple example on how you use JavaPoet to generate source code. So what you do is, like, you create a method spec, which is the main method, and then you add modifiers to it. So this is a public static, and the name of the method is main. And then you have, in case you need to add parameters to the method, you add the parameter, and then a bunch of statements. You build it, and then you get a nice method. And then after the method, you start building the class. So we have a class called as greeter. And then we add modifiers to it, add the method that we previously built, and then finally you build a class. And then you just write it to a file, or do whatever you want to do with it. So this is how the generated code would look like. So this, when I talk about code generation, don't think of very complex. Think of me doing a presentation here on how to generate JSON, right? That would be very silly and easy as well, right? So it's just because we are not familiar with generating code, that doesn't mean it's difficult, right? It's just unfamiliar to most of us, but once you get the hang out of it, it's going to be so natural, right? Like whenever I say code generation, think of like JSON generation, so you wouldn't have a trouble generating JSON, right? And then once we know that we have the appropriate tool to generate the source code, so the idea is that you have this huge CSV, right? And what does it contain? It contains tons and tons of data, right? So the objective is to have those data into a structure that can hold it for you, right? So the same data that was in the CSV, you're just moving it into a Java structure that can hold all this data, right? That is the idea. So when you blueprint, so this is our, when you do a blueprinting, you also have to start from the result. So how do you want the result to look like, right? So this is my end goal, then how do I design to build something like this, right? So what you do is you iterate on paper. You go take a piece of paper, sit in a quiet place, then start doing it on paper. Why paper? Because it's really quick to iterate. You can really design really fast. And then if it doesn't work for you, just tear it away and then start afresh, right? Don't use the IDE, don't use any digital media, just use paper, because you're not writing code to solve problems, you're writing code to generate as another set of code. So this template that you're going to write has to be really, really well designed. because any changes to the structure would also require drastic changes in how you write the generator, right? So you do a lot of iteration on paper, and once you have enough confidence that you've got it right, and then go do a prototype on your IDE, right? So you have the structure, and then go to your IDE, write down how the generated structure would look like, right? Because that will give you a really nice idea on how you're solving this problem, right? So we figured out we need two components. One is like a CSV parser to just parse the CSV from the Excel sheet, and then a source code generator that could actually take the generated data and then generate more code for you. This is a very high level design. I'm sorry about the contrast. So these are the classes that we wanted to generate. So tracker, when I talk about tracker, so it's unlikely that any company would be staying on with the same provider for a very long time, right? Could be different reasons. You find a different technology that is far more superior, or you may also find a solution that gives you better pricing. So there's a lot of things that could go on. Maybe you want to switch from Google Analytics to Mixpanel, or from Mixpanel to Localytics. That could happen at any point of time. So what we came up with was an abstraction called as tracker, which is just an interface. So what you do is like you implement a concrete, you create a concrete implementation based on the interface. So that way, tomorrow if your business team decides to go with a different provider, you don't have to worry about the code that is generated. Just throw away the tracker implementation and give it a new one, right? And this is also very powerful because I'll come tell you how we leverage tracker to do other things for us. And then you also have a class that is called analytics that is generated, and the sole purpose of this analytics class is to hold a set of workflow methods, right? And then you have all these classes of generated, like a tracker, the analytics, which will have all these workflow methods, and then you also have workflow classes, so which each and every workflow class will represent a workflow. So for example, if you want to cash in, then there will be a class for cash in. If you want to change your profile, then there's going to be a workflow for change profile, and if you're going to withdraw your money, there's going to be one more workflow for withdrawal, right? So each and every workflow will represent a goal, user's goal in the application, right? And then each and every workflow can also have multiple screens. So when you're going to cash out, then you have a screen where you enter money. You have a screen where you pick your bank account and things like that. So each and every screen class will also have a set of methods that will allow you to collect event data, right? So this is the objective. So we need a syntax that actually gives you a workflow followed by the screen followed by the event that you're doing. So this is a very rough idea about how our classes look like. So you have the tracker, and then each tracker has and you supply the tracker to analytics. So analytics, if you look at it, it has like the workflow method. So you have a savings workflow, you have a send money workflow, you have a get started workflow. So the analytics class will provide you all these instances of workflows, right? So and each and every workflow would have, say for example, savings would have multiple screens, which would be a deposit, a withdrawal, or a edit goal, right? So that's how it pans out. So savings, and then each and every screen would also have methods that would track events for you, like opted it. If you want to add Kite Cash, if you want to move savings to Kite Cash. So the way these classes are generated is from the columns. So you have these columns which tells you like this is the screen, this is the action, and this is the event that I want to track. So what you do is like you convert all those names. Say the name of the screen becomes the name of the screen class, right? Name of the workflow becomes the name of the workflow class, and the name of the event that you're collecting, say for example, add money, would become the method that allows you to collect that, right? So that's how you translate. So the data from the worksheet also becomes the names of your classes that you are going to generate. So the tracker class has just one method. So it gets an event and it gets a payload. So it's a what do you call it? It's a set of key value pairs. So your implementation, if it is Google Analytics, you do what Google Analytics is supposed to do. If it is Mixpanel, do what Mixpanel is supposed to do. So you have the event and this is the payload. So, and taking each and every class in depth. So analytics class is the entry point for your analytics. So you have the analytics class, and then this analytics class has a set of workflow methods. So when you call one of these workflow methods, you'll be able to access the event, the screens that are relevant to this workflow, right? And then once you get hold of the screen, you will be able to get access to the events that can happen inside the screen. right? That's how it pans out. So workflow is a top level class, and then it has a lot of inner classes which will be screens. So if it is caching, then you will have enter amount screen. You will have pick your payment method, which would be your bank or a credit card, right? So you have a workflow, and every workflow will have a set of screens inside it, which are again inner classes. In screens, these are inner classes, and screens will have methods that are events that can happen inside a screen. Say for example, you have a screen enter money, then you could have events like enter amount, you could have cancel amount, or you could have proceed to pick a payment method, right? And then events or methods inside the screen classes. So these are like the more granular ones. Say for example, you have enter amount, and then you also have to collect how much amount the user entered. So that would be a parameter inside the method that you're calling, right? So very high level idea. And then this was the design. So we came up with a structure that could actually generate this for us, right? So once you have this, we were able to generate Java code. And the problem is like, when you have to support multiple platforms, then there is also iOS. iOS also is something that you have to support. So when it came to iOS, we had a few unique problems that are specific to the platform. One is it's Swift, because Swift is a very new language. It's really young and it's evolving. Like there are 4 versions within like 4 years. So people don't spend much time on creating libraries that can either generate Swift code or transpile code from one language to Swift. So that was something that was lacking, and we didn't find any transpilers that could do that. So that was something that was challenging with Swift. But we realized that we came across a tool called J2 Objective-C. So J2 Objective-C is a tool that could generate that could convert your Java source code into Objective-C source code, right? And Objective-C is compatible with Swift. So what you're essentially doing is you can have Java code that can be used on Swift as well. So that's how we managed to do it. And then like life was peaceful because we have all these code with us, except it was not, because what you do is like the protocols that are Objective-C protocols are not compatible with Swift for some reason, right? So when we designed the tracker for the first time, it was designed to be an interface, but later on we realized that there is an incompatibility coming in. So instead of having an interface, we resorted to an abstract, right? Semantically, it doesn't make much sense, but in order to have a compatibility with Swift, we had to do this, right? So use abstract classes and not interface when you're designing classes, right? And then there's also nuances when you use Objective-C. J2 Objective-C also has a runtime library. Say for example, you have a set of classes in Java that are not available in Objective-C, then J2 Objective-C will also ship the runtime along with it, right? And the runtime is about 10 MB, so it really depends on what 10 MB means to you, depending on the kind of market that you are targeting. And Kite, being a company where most of our users are in India, like 10 MB is really huge for us. Like we can't afford to have 10 MB, or we can't afford to ship 10 MB with our application. So there's a way to work around this. Whenever you have platform specific implementation, say for example, you have a hash map or a date that is related to Java, instead of doing a concrete implementation, do abstraction, like maybe supply an interface that will do that for you. So if you're able to abstract away a lot of platform components, then you'll be left with only the skeleton. So that way you don't have to ship the runtime with the project, right? So benefits, accuracy. So assuming that your code that you wrote to generate the code is accurate and bug free, you're essentially giving the BI team whatever they're asking from you, right? So accuracy is guaranteed because humans are not doing the job for you. And then how do you deal with changes? Say for example, my business team wants to add a few more items to the event data, or wants to remove a few items out of it. Then what we do is you get the new sheet from them, and then you just regenerate the source code. So once you regenerate the source code, what happens is that if you look at this, you have a compilation error, right? So the events that were removed from the Excel sheet would not generate appropriate methods. That would result in a compiler error. And what you can do is you can navigate through this compiler errors in your IDE and then remove events that were not related. So you don't have to go to a business BI person and ask him like what events were removed, what were added, and you don't have to do a diff on the CSV sheet. to find out which events were added and which events were removed, right? And even if you do a diff, then you have to manually navigate through the code, which is like kind of more painful. But leveraging the compiler to help you out, removing this thing is like a really good way to do it. So this is on Android, and it also happens on iOS. So if you're using Xcode, you get similar results. So what we're doing is like we are leveraging the compiler to help us out when like item events are removed from the sheet. And then what if your business team adds more events to the sheet, right? So once they add more events to the sheet, what you can do is like you can navigate back to your generated code. You obviously know which files have changed because Git will tell you like these are the files that have changed. So you go to the files that were changed and then look into methods that have yellow markers. Like say for example, like it's not so visible here. So these are methods that have not been used, right? So like these are the events that I've missed. These are the events that I'm not tracking, and then you can go back and improve it. So this is an IDE feature that you can leverage to help you out to find out which events have not been added. So it's a nice way to cut down the communication overhead that has to happen between two people. So the communication is the sheet, and your communication is the Java or the iOS code that is being generated, right? So you cut down a lot of communication overhead that goes back and forth between teams. And then this also happens with iOS. So this is one of the unused methods. And talking about productivity, it's a no-brainer. You get autocompletion for free. So you don't have to look into your Excel sheet and find out, oh, okay, this is the event that I have to put in, this is the key, this is the value. You don't have to bother anything about it, but because you're acting on a much higher level, right? You get that autocompletion. So it's. And then you also get an implicit checklist. So you don't have to do your own checklists. So if you look at the sheet, like these are the events. You don't even have to look at your CSV. You just have to look at this code, and okay, I'm on the screen, and I've had 2 events, and these are the events that I have not had. So it also kind of serves as an implicit checklist. Same thing with iOS. Testing. So we test applications. We make the code testable using 2 things. One is like the schemes on iOS, and we also have built variants on Android. And then we also heavily rely on dependency injection to swap trackers that we ship, right? So these are some of the trackers that we have. So the first one is the log tracker. So whenever we are developing the application, the developer actually swaps a log tracker. So whenever you are tracking an event, you can actually see that on the logs. So you just see in the logs and nothing happens. Okay, yeah, I'm tracking the right event in the right place. And then there's a mixed panel tracker, which is the production tracker. So we have a couple of production trackers as well, with 2 different keys. So this is what goes into your production application. So that is fine. And the third one is the dialog tracker. So what the dialog tracker does is we ship a special build variant to the QA team. So they have this Excel sheet, and they also have the app with them. So whenever the dialog tracker receives an event, it shows a dialog on the screen, right? So it facilitates a certain degree of manual testing to your analytics code. So if the data that you collect is so critical, then it makes more sense to actually have your QA look into it, right? So this is a very subjective topic, like how much testing your organization needs is totally dependent on you, and you are the first person to decide what kind of measures you need to have in place to actually test the analytics code that you ship, right? The last one is very interesting. It's a verifying tracker, but it's a shame that we are no longer working on it. So the idea behind a verifying tracker is to write instrumentation test cases, and instrumentation test case would verify that data against the CSV, so that you don't have to have a QA to work on it. But it's like a bunch of it's a lot more overhead, and we thought like the engineering effort required to do it is not worth the price that we are willing to pay, right? So we are happy with manual testing. So these are some of the code generation tips. So the first thing is like I don't usually recommend violating a lot of good principles, but when it comes to code generation, I would rather not have the code to be dry. It is okay to be dry because you're not the ones who are going to maintain the code. So you have to design the code in such a way that is just so easy for you to generate, right? So if you bring in a lot of reusability, or if you build complex structures, then modifying the code is going to be very difficult, right? So it is acceptable to have a certain level of repeated code in the kind of code that you generate. And then you iterate through your design several times before writing your code generator. Don't just jump into it, because like once you start writing code that generates code, it's like it requires a little bit of patience and a well-planned design. Add auto-generated comments and documentation, do whatever so that people will stay away from your code and not attempt to modify it manually. One thing that we do is like in addition to adding these uh, comments to the source code, we also prefix the file name with a dollar on Android. And abstract classes over interfaces, and make sure that if you don't want to ship the runtime, extract platform specific code, and then communicate with the BI team. Like they have to know what you're doing. Just because you learned a technique, just don't go ahead and try it secretly, because when you don't want people from your BI team throwing surprises at you. So you have to communicate that way. Any transition that they're going to make, you are so well aware of, and then it does not take you by surprise, right? And a few more things is that make tools that work for you. You have a lot of tools at your disposal, most of which we take for granted. So once you start looking at them in a different way, you will figure out ways how to make the tools work for you. In this case, we did make good use of the IDE as well as the compiler to help us through the process. And then developers should always do meaningful work. So if you find yourself doing repetitive work, boring work, or work that does not add any value to business needs, then probably it might be a good candidate for you to automate, right? So code generation is just one way to do it, but there's a whole lot of things that you can do to make your life easier and for other people that work with you. So also it helps to have awareness about the kind of people that you're working with, because a lot of people are involved in the kind of work that we do. Like you ship code, but like you have people who have to test it. You also have people who rely on the kind of functionality that you ship to build a business around it. So it helps to actually think at their line, so that you build a solution that is far more superior than what other people ship in the industry. And code generation is not hard. It is not at all hard. It's just unfamiliar. So like think of the days where maybe when you were in college, you heard all these fancy terms like polymorphism, inheritance, and then dynamic dispatch, and all those things that they look so fancy, so complicated. And like now when it comes to functional programming, like you hear monads, and like you have composability, you have pure functions. Like there's a lot of fancy terms going around, and it's not difficult. It's just you're not familiar with it, right? Code generation is also similar to that. It's like you have been writing code all your life, but there are like a lot of things that you can automate. Say for example, if you see yourself working on a pattern which is constantly being repeated, or a set of code that's constantly being written by developers, those are good candidates to actually automate. So just try it once. It's really hard. It's not at all hard. It's just unfamiliar to us because we have never spent much time in these areas. And that's about it. If you have any questions, I can take them. Yes. I don't have a sample project yet, but I wouldn't mind putting it on the internet. I will do it like as soon as I can. Okay.
Hello. Hello. Can you hear me?
A little bit.
Hello.
Yeah, loud and clear.
My name is Aditya.
Hello, Aditya.
So the first question is, I basically have two questions here.
Uh-huh.
So the first question is, do you have, is this an open source project, or are you considering it to be open source soon?
Yeah, this is, I don't see, okay, so one question that I get frequently is like, can this be a library? Can it be open source? So I don't see how this can be a library, because like I don't see a common denominator where the need would be common for several people, but I would definitely like to create a sample project so that people can actually look into what I'm talking about.
Okay. So the second question is around the payload of event tracking. Do you have suggestions or solutions around how we can declaratively create the payload itself?
So declaratively creating payload is what this does. Like say for example, when you have a payload, the code essentially encapsulates the payload within itself, right?
Sure.
So you have maybe 10, 15 or 20 different fields or data that you're tracking, and if you want to do it declaratively, then again it's going to be a lot of work for you. Okay. Right? So the idea is not to fetch the data manually or involve a human being in getting the data. So declarative, we did think of it, but we were not convinced with the kind of solution that we came up in the beginning.
Okay, so last question.
Right.
So imagine that I have a design pattern or an architecture in which there are a lot of components. Components which are reused across two different screens. So how could I write tracking in such a way that since this component could be present in both screens, screens could be different, right? So how would you manage the consistency of tracking in this case?
So basically, you know, one thing is like the code that is generated. I forgot to mention, it's completely stateless, right? So it does not have any state at all. And when you say it is the same event but happens on different screen, then you'll have two different classes that would have two different methods. So like it does not interfere with what you are actually doing. So that is not really a problem. Say for example, enter amount screen would be in cash in as well as cash out, because when you're trying to load your wallet with money, you're going to enter how much you're going to load it, and then when you're trying to withdraw it, again you have to enter the amount of money that you want to withdraw. So these are clearly two different screens, but they don't interfere with each other because they are at two different places.
More questions? Okay.
Yeah, like method count, it should be pretty negligible, I think, because it always boils down to how many events that you're collecting from your application, right? And then we have multi-dex, so this is primarily not a concern at this point of time. Like 300 more methods, which is like very minuscule. Correct. At our scale, it is acceptable, and it should be. Like I don't really can't think of a reason why it would be a problem, like even large code bases.